What's up guys, today we'll see the open Brayton cycle. Open Brayton cycle, joule cycle or gas turbine cycle, everything is one only. So let's get started. Main component, compressor, combustion chamber, turbine. First thing first, compressor, right? So what is a compressor? Compressor, it compresses the incoming air. Now this compressed air go to the combustion chamber where we are burning the fuel. So basically we are adding the heat, adding it. Arrow is given, q is given, so it is adding the heat. So now high temperature and high pressure gases go to the turbine. In turbine the expansion of hot gases occurs, and due to that shaft rotates and power generation or power production takes place. This is connected to the generator, right? So and one shaft come from the turbine to the compressor. Now turbines 40% power get consumed to work the compressor, rest is for the power production. Where we are using this, so we are using in the aviation industry, uh, that gas turbines, or you can see that big engines, G or Rolls Royce, these only. In real life they are very complex, but this is the schematic diagram, but working on the same principle only. In that case what happens, the exhaust get used. We are not connecting the generator, though exhaust is used as a jet, and due to that propulsion is occurring. So let's come to the thermal point of view. So in it can mainly can be divided into four cycles: 1 to 2, 2 to 3, 3 to 4, and 4 to 1. Now open, it means exhaust will go out directly. In what happens in a closed cycle, here is a closed cycle. Now combustion chamber is replaced with the heat exchanger, and here is also one another heat exchanger. This heat exchanger supplies the heat. This heat exchanger takes the heat, or rejects the heat from the system, right? Combustion chamber is added outside, so fuel burning here, burning of the fuel is here, and through that the heat is transferred from the hot gases to the gases or any fluid which is going into the system or circulating in the system. It takes the heat, and same compressor compress everything, then go to the heat exchanger, take the heat, expansion, power production, and then the rest exhaust gases will come here, and uh, it contains some very low grade energy, but though heat, it rejects that heat and once again go to the compressor. And it has basically four power cycles, four processes, sorry. 1 to 2 isentropic compression, here isentropic compression in a compressor. 2 to 3 heat addition at constant pressure. 3 to 4 uh, isentropic expansion in turbine, and 4 to 1. Here we can say 4 to 1 because it is an open cycle, but come here, 4 to 1 heat rejection at constant pressure. So here is a PV diagram and TS diagram. So let's start first with the TS diagram. Process 1 to 2 isentropic compression. Now what happens in an isentropic process, the entropy remains the constant. It means we are not adding any kind of heat, or we are not rejecting any kind of heat from the system, so the entropy of the system remains constant. So S is equal to constant value, same value, let us take it as S1, right? So S1 is equal to S2. but temperature is increasing because what happens in a turbine, the air is compressed, and due to that compression temperature of air gets increased. So entropy remains the constant but temperature increases. Now process 2 to 3 constant pressure heat addition, that is combustion chamber. In 2 to 3 what happens, we are burning the fuel at constant pressure, so temperature is also increasing, we are adding some amount of it, so our entropy is also increasing. So 2 to 3 increasing, right? Same in turbine but in the reverse direction, isentropic expansion. So what happens, isentropic process means no heat addition, no heat rejection, entropy remains the constant. So S3 is equal to S4, right? S3 is equal to S4, but it takes the energy, or we are basically expanding the gases. So what happens during the expansion, average kinetic energy of the molecules are decrease, so temperature get reduced. Same reverse for the heat rejection process, constant pressure heat rejection. Same, during we are rejecting the heat from the system, so temperature and entropy is also decreasing. Now come to the PV diagram. Pressure 1 to 2, we have compressor. Now what compressor? Isentropic compressions. So during the compression process, but obvious, if you are compressing something means volume is reducing, so in this direction we are going, that is volume is reducing, but we are compressing, so pressure get increased, so pressure get increased. Now 2 to 3, that is heat addition at constant pressure. So during the heat addition process, volume is get increased but pressure remains the constant, so constant pressure heat addition, that is Q here. Now 3 to 4, isentropic expansion in the turbine. So isentropic expansion, obviously expansion, so volume is increasing. And 4 to 1, heat rejection. So that's it. Thanks for watching. Have a great day. Don't forget to like, share, subscribe and comment on video.